Can you imagine having your brain controlling and operating smartphones, personal computers, smart TVs, even smart cars, and all your tech gadgets you have around you? Or having the technology to cure some physical disabilities? In today's video, we're going to be talking about Neuralink, a company founded by Elon Musk in 2016 with the mission to make breakthrough technology for the brain. Over the last years, Elon Musk has raised his reputation for disrupting several industries, from banking, rocket, automotive, and energy, and has become some sort of tech Jesus. But for sure, among all the companies founded by Elon so far, this one is easily the most abstract and hard to understand. Recently, Elon Musk finally showed some of the technology being developed to the public for the time, and according to him, the aim of developing the brain chip is to implant the chip in disabled persons, allowing them to control phones and computers flexibly. But just as we may expect, if disabled persons can successfully use Neuralink without any lingering health issues, the sooner a normal citizen will get it implanted into their brain, and before anyone will say Jack, it would be a fast-growing trend. But the idea of a brain device to control devices, actually, it's not new. Back in 2004, researchers from Brown University started a project called BrainGate, and in late 2018, they demonstrated that they could enable people with ALS, aka Lou Gehrig's disease, to control an iPad simply with their thoughts. Can you imagine that? That's the first step that Neuralink is expected to take, and would be an amazing step forward in the quality of life for people who suffer from paralysis. They would be able to communicate and express themselves, read, browse the web, or even create artwork just with their mind, going beyond just controlling a tablet using the same process. A cardiologist could control a prosthetic device, and there is a precedent for this technology as well in most cases. The paralysis is caused by a broken connection between the brain and the muscles, so we can bypass the broken link to get signal from the mind to the muscle. And this is absolutely possible for people to regain the use of a paralyzed limb by having an external device that fires an electrical signal straight into their muscles. But the main issue with the Utah array, which is the technology used by the BrainGate project, is the material properties of the electrodes. These electrodes are like stiff and sharp needles, which allows them to penetrate the brain and record the internal activities. But this causes problems with the body's immune response. This is the first part of Neuralink plans to improve this technology by making these electrodes much smaller. The Utah array's electrodes varies from 0.03 millimeters at their top to about 0.1 at their base. Neuralink threads are much smaller, at about 0.004. The Utah array allows for up to 128 electrode channels. Not only these have fewer channels than what Neuralink promised, but fewer data from the brain can be picked up. The Neuralink surgically implanted in a rat and successfully recorded from has 96 electrode threads, which contain 32 electrodes for a total of 3,072 channels to read from. Making the threads thinner allows them to affect a smaller portion of the brain, making them less likely to affect nerve function and to puncture blood vessels. But perhaps more critically, makes the threads more flexible, allowing them to move with the brain and it jiggles around the skull. This is a huge problem, as you probably can imagine. The tissue in the brain is very soft and elastic, and if you have a stiff needle, like electrodes fixed in place, the brain will simply deform around them. This causes scar tissues to form around the needle, which over time will block the needle's ability to read brain activity through the scar tissue. Matching the electrode's material properties to the brain as close as possible will allow the electrode to move and deform with the brain, and thus decrease the scar tissue, forming and extend the life of electrodes, a vital design parameter for medical implants. So Neuralink has moved away from these stiff silicon electrodes to create a thinner, flexible gold electrodes coated in a conductive, biocompatible thin film polymer. But electrodes like these comes with their own issues. Their small size and flexibility making them very difficult for even the skilled hand of surgeon to insert. So Neuralink has also developed a robot electrode inserter to lend a helping hand. Scientists from Neuralink hope to use a laser beam like a photographic implantation to get through the skull rather than cutting the skull as demonstrated in traditional surgery. So you can imagine, just if you decide to get your Neuralink brain device, you just pop to a clinic and you can get it implanted as fast as you can imagine. This is expectations. The experiment will be carried out by neuroscientists at Stanford University, and according to report, Musk already said in a comment that they hope to get it successfully implanted in the brain of a human patient by the end of 2022. Can you imagine that? As for Elon Musk, the main problem of interacting with AI is bandwidth. If the Neuralink is successfully implemented in the brain, humans can take information much faster than it is pushed in through the command of the voice or thumb. In a recent paper, it was confirmed that Neuralink was improved to a custom chip that is better able to read, clean up, and amplify signals from the brain. But the limitation is that right now, signals can be only transmitted via wired connection to the brain through a USB Type-C port. But this is just for a test, because the goal is to create a system that can work wirelessly. The wireless goal will be embodied in a package the Neuralink calls Type N1 sensor, which will be implanted in the human brain and can transmit data wirelessly. Right now, Elon Musk said that they are still testing the chip in the brain of a rat to make sure it works as desired, and as well make corrections where necessary. If the technology works as desired, then it will have a higher bandwidth connection. According to Siobhan Zilis, the project director at Neuralink, the journey to have this technology publicly available will take 10 plus years, and adding this time, all the process for clinical trials to get the FDA approval. It's gonna take a while. But now I want you to imagine with me the security risks associated with the technology like that. Imagine that what would happen if this device can be hacked, and how the data that this device will be constantly collecting from us, how they will keep this secure. There's tons of points to figure it out to start using a technology like this. Guys, as always, thank you very much for watching, and if you like this content, please hit the like button. And don't forget to subscribe and activate the notification bell so you don't miss anything in the future. See you next week.